Hey everybody, welcome to Gradeful's daily live stream. Today we have an ACT math lesson picking up where we left off the past few days. This will be part 4 of the must-know ACT math formulas for the math section. And again, as always, we're here from Monday to Friday at noon. You can check out our website, gratefultestprep.com. Check out our YouTube page you're on right now. There are many videos for the SAT, full test answers, different lessons in math and in reading as well. And my name is Patrick Spano. I'm one of the hosts of this daily chat. And we have Mr. Alex Torres, the other host. I'll let you go from here and explain a little bit what we'll be doing in today's test prep chat.
Sounds good. Okay, so we have been going through lots and lots of different things to have memorized for the ACT math section. You know, these are content-based tests, and it doesn't get any more content-based than the ACT math section. It's extremely comprehensive. A tutor can do, 20 practice tests with you, and on the 21st, there will be some little mini concept in there that we haven't seen in any of the previous 20. So what does that mean for you as you're preparing for an ACT? It means that there's high accountability. Like, for instance, if in your studying, you come across the law of cosines or the area of a rhombus or something like that, consider yourself responsible from that point onward to remember that concept from now on, because you may never see it again until your ACT when you really need it. So we'll go ahead and jump right through into some of the things that we need to know. And there's a little bit of repetition if you've been following our playlist for things to memorize on the ACT. Some things are coming up more than once, which is great because you need to see a lot of these things a couple of times, maybe help drill them into your memory. So the first one I wanted to talk about today is going to be the distance between 2 points on a coordinate plane. So let's just say we have the points 4, 7 and -5, 3. And we're being asked for the distance. Now, by the way, in school, you might be told that in this situation, you want to use the distance formula. We at Gradeful highly disagree with that view because we feel that the distance formula is the most confusing of all the formulas. And also, well, first of all, it involves addition, subtraction, exponents, radicals. It has all the things all at once that any of them can confuse us, especially when they're all put together at once. But what is the distance formula? The distance formula is what you get when you take coordinates and plug them into the Pythagorean theorem. So if you're someone who's familiar with the distance formula, you may kind of notice that we're doing the same operations anyway, just that we're doing them with a little less of the risk that we'll get something wrong. So if we have the points 4, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So that's the point 4, 7, -5, 3, 1, 2, 3, 4, 5, 1, 2, 3. So here we have -5, 3. The way we recommend for you to do the distance between 2 points is to create a right triangle and use the Pythagorean theorem, which, like I said, that's where the distance formula comes from. So here's a right triangle. And now that right triangle is basically expressing the fact that this diagonal distance can be broken down to a vertical and a horizontal component. So in other words, in order to get from here to here, we have to first get from here to here and from here to here if we were only allowed to go straight up and down and straight left and right. So now what are these distances? Well, the horizontal distance is the distance between x equals -5 and x equals 4. So you can kind of see that as going 5 in this direction and 4 in that direction if you are more of a visual thinker, which would be 9. And we can also think of this as 4 minus -5. So when you want distance in a number line, you're going to want to do subtraction of the bigger minus the smaller. And if you're sort of really someone who's really well aware of all this kind of thing, then you'd know that that's what absolute value is for being able to subtract without ever getting a negative answer. But 4 minus -5 is the same as 4 plus 5, which is also 9. So now the vertical distance could be thought of as 7 minus 3, like we just said, or you could kind of count it off here because it's that easy. But that's a distance of 4. So now to get that distance, we'll just go ahead and use the Pythagorean. A squared plus B squared equals C squared for a right triangle. Most important thing about the Pythagorean is that the hypotenuse has to be C, you're ever dealing with a harder question where maybe you're given the length of the hypotenuse. And so that's 4 squared plus 9 squared equals c squared. 16 plus 81 equals c squared. And I wonder what calculator guy thinks about all this.
Caught me off guard.
Yeah, you don't deserve to be called calculator guy. I'm about to make this the last time ever. So we have 97.
It's unbecoming.
Square, yes, exactly. Of your level of amazingness, which is extremely high. Square root of both sides is 9.8. And so the distance between these points is 9.8. So although we don't have the time to go through it now, a harder question would be one where we tell you the straight line distance between 2 points is 9.8. The horizontal distance is 9. What's the vertical distance? You would do all the same things, but you would plug in what you have, and the variable will now be the vertical distance. So it essentially would be the same operation. So what do you think about that one? Mm-hmm.
Very good. I think that it makes it much simpler. Yeah, this is exactly how we like to teach it for students. The less that you need to memorize, the better. And again, for anybody who is going to be watching right now, this is part 4 of our ACT must-know math formulas. The first 3 parts are available on our YouTube channel under the ACT math lesson, the playlist for that. And yeah, for anyone tuning in, we're going to keep on going here. So I'll send it back to you, Alex, to keep on bestowing some wisdom upon us.
Nice. Now, while you're watching this, especially if you're a parent watching this, notice how hard it would be to advance on your SAT and ACT goals without the right training, without the right tutor there to help you. I might even consider it kind of impossible. Maybe not. I mean, if you're a really driven student and you're going to be taking all the free lessons that a company like Gradeful is going to be putting on YouTube, you can definitely make a lot of headway. But if you're someone with the resources to do one-on-one tutoring, I definitely advise it, because what are we looking at here when we look at the distance between 2 points? We're looking at the fact that over a tutoring career, we might try one way of solving a problem, and when we see something better, we latch onto that, and it continually evolves. So when you have someone guiding you through one of these tests who you trust, you're going to get the best way for every situation, and you can focus your energy on making the best progress you can in a short amount of time, because we know that SAT and ACT is not the only thing in your life. So the next one is going to be the midpoint of 2 points, and the midpoint formula has an X component and a Y component. And the formula is basically the idea that we are averaging the X's and we're averaging the Y's. So that's the midpoint formula. Unlike the distance formula, we don't have a way around this formula. You definitely want to have it memorized. So just, nice and easy. If I said, find the midpoint of, and I just give you 2 points, 1, 2, and 3, 4, nice and easy. You can kind of label the first one as x1, y1, the second one as x2, y2, just like we do when we're finding slope, and then just go ahead and plug them in. So the midpoint would be, x1 plus x2 over 2, y1 plus y2 over 2. And as you solve those, 4 over 2 is 2, 6 over 2 is 3, and we just found the midpoint. But maybe more importantly here, if you were to get a problem that had maybe the level 2 version of this problem would be something that gives you the midpoint and one endpoint. So the midpoint is, let's say, 2, 3. One endpoint of a segment would be, let's say, -1, 5, with better handwriting than that, -1, 5. And then the question would say, find the other endpoint. And so we can take the same formula and plug in everything we know. So we know the midpoint is 2, 3. We know one of the endpoints is -1 and 5, but we can keep the rest of the formula the same way it already is. And when we're doing this kind of a question, we need to realize that this X value was produced by this part of the formula. Therefore, they go together. 2 equals -1 plus x2 over 2. And we can solve for x2. Multiply both sides by 2. Add 1 to both sides. And we found x2. In other words, we found the X value of the other midpoint. And now we can do the same thing for the Y value. We can realize that this 3 was produced by this part of the formula. So we can pair those up together. So we can say 3 equals 5 plus y2 all over 2. And now multiply both sides by 2. Take away 1. And the y value is 1. And so now we've got the other endpoint. So the other endpoint is 5, 1. And so if you have a segment that has an endpoint at -1, 5, another endpoint at 5, 1, just noticing the similarity of those numbers, the midpoint is 2, 3, and we completed the story there.
Very nice, very colorful as well. I'm sure that was on purpose.
I guess so. I know you're thinking of the comment that was left where the person said, I hate when they switch colors so much. But you know what I think they were referring to? I think the person was referring to how in the older version of Microsoft OneNote, there was a more arduous process of picking the next pen. So it's like whatever you're reading disappears every time somebody switches to the other pen, which is definitely one of the things I like about this version of OneNote. So
much more seamless.
Yeah, definitely. So, okay. So another question that you should be ready for on an essay, an ACT, and it does also come up on the SAT, is to find the domain and range of a function. So finding the domain and range. So when we're talking about the domain in particular, we're talking about avoiding excluded values. And there are two things that should be excluded in the world of math, at least in the high school level. Number one is getting a 0 in your denominator. And number two would be having a negative under a radical. So if you're being asked for the domain of an expression, so for instance, y equals 3 plus square root of 2x minus 5. Okay, and the question says find the domain. In other words, well, first of all, what is domain? Domain is all your possible x values, and the range is your possible y values. But the way it works is you find the possible x values and you plug those in to find the y values that go along with that. You don't necessarily do this process twice. So now what the rule is here is that we cannot have a negative under the radical. There's no numerator or denominator here to speak of. So the way to find the domain here would be to say, okay, I have this thing under the radical, and that thing can be equal to 0 or it can be greater than 0. And this is an expression of our domain, and we just need to solve it. So 2x greater than or equal to -5 divided by 2, x greater than or equal to -5 over 2. So now we know this has to be restricted to x values that are greater than or equal to -5 over 2. And this is our domain. And I may not necessarily explain it in this moment, but now if I were to find the range, I would start by plugging in -5 over 2 as x and values that are greater. So that's -2.5. So -5 over -2.5, -2, -1, 0, and 1, and start to figure out in what direction does y go as x starts at -2.5 and goes greater. So that would take a little while there, but that's how you do it in terms of finding the range. Now, let's say that we had to find the domain of this expression right here. Y equals 5x minus 2 over 7x plus 4. So we're finding the domain and therefore finding the range. But the idea is that you cannot have a 0 in the denominator. So what should we do here? We should go ahead and set the denominator equal to 0. That would happen if this were linear or quadratic or something more complicated. And then go ahead and find out by algebra what values would have caused this to be equal to 0. So just solving the algebraic steps right there, we're seeing that x equals -4 over 7 once the whole thing was set equal to 0. So in other words, the x value that makes the denominator equal 0 is -4 over 7. So the domain would probably look something like x cannot be equal to -4 over 7. Or if you want to know the fancier way that a lot of people see in algebra class, the domain starts at -infinity and goes to -4 over 7. And it gets combined with -4 over 7 going to infinity. And if you know this method, you know that the round parentheses tell us that they're not actually part of the solution set. So these round parentheses are telling us skip the number -4/7 and include every other number besides that.
Very well said. And I think this just goes to show that domain and range could make up a video on its own. I think maybe that's something for the future. Again, we have lots of ideas. If you're watching this live or if you're watching it later, comment any ideas that you would like to see us cover. But I think that maybe that might be a good video topic on its own. Domain and range, there's a lot there, a lot to know. And you want to get those types of questions right on these tests. And sometimes they're very small details that can separate which answer is correct and which are wrong. So you want to make sure that you have all that information down pat. Very good explanation.
Absolutely. And if you want another concept that definitely merits its own lesson, we're going to talk about logs right now. So log shortcuts are things that, you know, a lot of questions can kind of quickly test if you understand a certain log shortcut. And I'll show you some of those really quickly. So for instance, one rule is that the log of A plus the log of B equals the log of A times B. So in other words, when you're adding, it's akin to multiplying in the world of logarithms. Now, a lot of these little rules that we'll be showing you here, they can easily be confused with other rules. So you got to really, really have them down. But a sample problem right there would be something that says, you know, the log of 5 plus the log of x equals the log of 14. And so now knowing the rule that we have on the left-hand side, we could kind of say, well, log of 5 plus log of x, that's the same as the log of 5x equals the log of 14. And so now that they line up a little more parallel, we can say, well, that must mean that 5x equals 14. And you can go ahead and divide both sides by 5, and you get your answer that way. So a similar rule would be that if you have log of A minus log of B, then the opposite of it is true. That's just like division. So that's log of A over B. So that'll be our second rule. And you can imagine a similar practice question. Log of 5 minus log of x equals log of 12. Now 5 minus x is the same as log of 5 over x. And then once again, we can say 5 over x equals 12. Multiply both sides by x, divide both sides by 12, blah, 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 and you get your answer that way. So we won't do the algebraic memory, little solving on that little one, just so that we can have more time to show you more log rules. Another important log rule is the log of a to the b power is the same as b log a. So what does that mean for us? We could get a problem that would say the log of 6 to the x equals 14. And for a lot of people who don't know about the log power rule, that could be really tough. So a lot of these rules are just nice, easy things that if you know the rule, then your life just gets so much easier. And if you don't, you can kind of be stuck and have to go to the next question on the test like the ACT. So the power rule says that we can take that x and put it in the other position, just like we took the b in the rule and put it right there. So now we can just divide by log 6 on both sides, and x is 14 over log 6. So just, a little list of rules here. And we have one last one, which is the change of base formula. It says that the log base A of B is equal to the log of B over the log of A. So how could we use that one? Well, for instance, if I knew that if I did a lot of solving and I got to the point where it said, okay, well, x came out to the log base 5 of 12, let's say, just awareness of this tiny rule could get you to the next step, where we basically now know that that means we can go into our calculator and just type in log of 12 divided by log of 5 and get whatever decimal answer that gives you there. And so, just plenty of these situations where without awareness of the rule, you'd be out of luck, as they say. And with awareness of the rule, then you can move on to the next thing and go ahead and impress colleges and get well on your way to achieving some of your dreams.
Exactly. So I think we're going to leave it there for today. Does that sound good to you, Alex?
Sounds awesome.
Part 4 of our ACT math formulas. Again, we'll post this video to the playlist. The other 3 videos are already up there. And again, as you mentioned, if you're watching in real time, if you're going to watch it later, our video library, many videos, many more to come, daily live streams. We'll keep you posted for next week, the schedule with the holidays. Of course, we'll see what the schedule will be, but this is a great time to start preparing for the upcoming tests. Again, on our website, a lot of information there. We can tutor you one-on-one. You can take advantage of the free videos, gratefultestprep.com, Facebook, Twitter. You can find us there as well. And any questions or comments, write them below. Subscribe so you get the notifications from when we go live. And if you want to chat, our phone number is on our site as well. You can email us or call us. We'd love to help you in any way that we can. So I wish everyone a very good weekend. Alex, I'll let you finish it off from here. Thanks for your help again, as always.
That's it. Take care, guys. Nothing else to say here. We hope you enjoyed our video. Have a great day.